So, Wiley assignments, I think they are all due except for 2.1. 2.1 is not officially due until Monday. However, your exam covering 2.1 is on Thursday. So, that being, I'm not going to move up the due date, but you might want to look at it and attempt those problems. They'd be good practice for the exam. Today we'll cover 2.4, and then tomorrow I'm going to review over everything that will be on the exam. So I gave you guys that review sheet. I also uploaded to Blackboard. Those are concepts that could show up. So, the review, review of college algebra and know how to, find the inverse functions, things that we've done in class, solve basic equations, simplify. If I have that a to a power divided by a to another power, know how to make it to a to a simple power, because that's beneficial on differentiating, right? If I give you a really complicated function, you want to simplify it before you begin to differentiate it, and you need it x to a power to differentiate it. So. And then all the way through 2.1. So those concepts are there. If you have any questions, prepare them for class tomorrow. I'll start with questions. So if you want to know how to do this specific problem, bring it to class tomorrow. If no one has any questions for the rest of the time, I'll just throw up questions and say, okay, let's try to do this question. This would be a good one on the exam, or this shown up on a previous exam, or these types of questions show up on the final exam. So things like that. Question.
Can we submit before class time tomorrow? Can we submit questions like via Piazza?
Yeah, that's fine. Definitely. Always use that. 2 instructors check it regularly and post on it, but anyone can post to it too. So definitely, everyone in Calc 1 will be taking an exam on Thursday. So everyone's in kind of the same boat, and most other sections cover up through 2.1. So keep that in mind, where you can study together and post questions and get the feedback there. And I'll watch it too. If something shows up, I can answer it on the message board, and if not, I can do an example in class too. Question?
Did you post a practice?
I didn't, and I probably won't. I post those topics, and if you just go, okay, let's do an example of this topic, that would be a good practice exam. The exam is going to be roughly 4 quizzes, if you think about, the type of things that are on the quizzes. So it'll be worth 100 points. Generally, I give a couple bonus in there for various things, so it's possible to get some bonus on each exam, but I'd shoot for it, to take 1 class time, so that's 50 minutes. So that's not a lot of time, so it has to be written where I can't give you too many problems, but then I can't have 1 problem be worth 20 points type thing if you have no clue how to start it. So I balance that. So.
Could you show us again where where those study resources were?
Yeah, so if you go to, that's a good question. If you go to Blackboard, I've been really bad at password lately, so let's see if I got it. And then if you go to your calculus page, and I put it with the notes as far as the study guide. So if you go to class notes, I have a folder called study guides. So if you click on the study guides, that's the first study guide. And every study guide I will put in this folder. So this is just the PDF of the handout I gave you guys in class.
So that Wiley one, there was the Wiley problems that happens, which was answers.
Yeah, Wiley has additional, I was already in Wiley, it's going to get mad at me. So if I go to your home, so this is what your guys' version looks like. You go to read, study, and practice. So let's say I go to chapter 1. There's practice assignments, which would be in Wiley, that would give you the feedback if they're right or not. But then there's also this study guide for chapter 1, so student study guide for chapter 1. And this study guide starts off with giving you an outline of chapter 1. It might hint on, okay, the purpose of this, be very careful for writing various different things. But where most students use this is for the multiple choice questions towards the end. So if you scroll down, it'll say, okay, this is multiple choice questions from section 1.2. So, and then the answers are at the very end. So you can use those resources to help study, and if something doesn't make sense, you can let me know. Does anyone have any other questions? Wiley does not like the back button. So yeah. The practice assignments, like 1.3, it would just be just like the assignment I assigned. So it might even be problems from the assignment. So if you want more feedback as far as, if I plug this in, is it right? It's not multiple choice. It's the natural to come up with an answer. You can do those too at the end of, if you just chapter 1 at the very bottom, these practice assignments. Any other questions?
Excuse me, regarding the grades, are they posted in Blackboard?
Your online homework grades in Wiley are just kept in Wiley. But your quiz and your written homework will be posted in Blackboard. And so I'm a little behind on uploading them, but they will eventually be. Probably later today I'll repost those. But it's good to keep in mind that checking to make sure your score you actually got is what I actually have recorded for you, and letting me know if there's any discrepancies. So I will try to post those later today, but I have them in my own Excel file. I upload that Excel file to Blackboard, so I'll upload it and it'll be there. So I think quiz 1 and quiz 2 are on there, but quiz 3 and written homework 1 is not uploaded yet, but eventually will be. Any other questions? Okay, so today we're going to cover 2.4, and 2.4 is more techniques of finding derivatives. So 2, 12, 13. And we're going to learn the product rule and quotient rule. Eventually, we'll use the product rule and quotient rule for more complicated functions. But at this point right now, we only know how to take a derivative of x to a power. That power can be positive, it can be negative, it can be a fraction, but we don't know how to take the derivative of sine, cosine, e to the x, ln of x, or any other functions. Eventually, we'll learn it, and we'll apply this technique to any function. So these are techniques for differentiating products and quotients of functions. Whose derivatives are known. So let's look at the derivative of a product. If you've had a chance to look at the Wiley homework over 2.3, they give you an example of one time that they have a product of two functions and they ask you to verify true or false if the derivative is going to be the derivative of the first function times the derivative of the second one by expanding that out and then using derivative of each term. It turns out it's a little more complicated than just taking the derivative of the first function times the derivative of the second function. So this is theorem 2.4.1, and this is known as the product rule. So if I have two functions, f and g, and they're differentiable, something to keep in mind that the derivative has to exist to be able to take the derivative. But we know from chapter 1 that if two functions are differentiable and I multiply them, that function's differentiable. So I'm looking at how do I differentiate a function times another function. Turns out you're going to take the derivative of the first function, hold the second function, plus the derivative of the second function, hold the first function. This is your formula. A little more compact way to write it, if I'm taking the derivative of a product, derivative of the first function, hold the second one, minus the derivative of the second one, hold the first one. Another way to write it would be, I don't know if your book, yeah, it is plus, sorry, thank you. Your book uses a little different notation, but it's meaning the exact same thing. course, you could write this f prime g plus f g prime, right? Because it doesn't matter what order you multiply. What you call the first function, what you call the second function. The derivative of the first one, hold the second one, plus the derivative of the second one, hold the first one. So I tend to write it like this. I think your book actually uses this notation. But don't get caught up on that. Question? It means leave it alone. So I'm taking the derivative of the first function times the second function. So derivative is an operation. I'm taking the derivative of a function. I'm operating the derivative on a function to get a new function. And then when I say hold the second one, I'm saying leave it alone. So just multiply it by the original function. And then take the derivative of the second function times the original first function. I don't know where it came from. I don't even know. I think your book uses maybe the term hold. That's what I was taught. Derivative of the first one, hold the second one. Plus the derivative of the second one, hold the first one. It means leave it alone. Yes?
How do you go from the top line to the bottom line? Like, how do you go
So-
to f times g prime?
Well, so this is kind of messy. There's a lot going on here. I really don't need to know this function's a function of x.
Okay.
So I can kind of drop that. And this is the differential operator. I can also replace that with a prime. So this is just saying f prime. So it's just a simpler way to write it.
Okay.
You know, here, and they're kind of the same thing. This one is probably what I'll use because it's what my hand knows. The other one is also correct, though. Yes?
Is there any way to turn that, like, lighting up or anything?
I couldn't possibly turn off the top lights. Is that better? Is that better? All right. Sorry about that. Okay. So let's look at a quick example just to kind of illustrate this. Let's say our first function is x and our second function is x squared. So what is f times g? X cubed, right? So f times g prime would be what? 3x squared, right? So that was knowing the function. But using the quotient rule, x times x squared, I should also get the same thing. Sorry, the product rule. Right? I take the derivative of the first function. I'm going to write this out in longhand and then simplify it. You don't have to write this step though. So basically what this is saying is I'm taking the derivative of the first function, leaving the second function alone, plus the derivative of the second function, holding the first function. So what is the derivative of x? 1, right? What's the derivative of x squared? 2x. So then I have x squared plus 2x squared. What's x squared plus 2x squared? All right, and we are happy because we got the same answer we got here. This is just an illustration of the product rule is the same. There will be times when foiling out and differentiating is quicker than product rule. There will be times where product rule is quicker than foiling it out. Both ways will give you the same answer. So let's look at number 6 in your book. So f of x equals 2 minus x minus 3x cubed times 7 plus x to the 5th. So let's first do it by 2.3 techniques by foiling it out. And then we'll use 2.4 techniques, the product rule, and compare our answer. So by multiplying it out, what do we get when we multiply this out? So I would have, let's see, did I do this over here? I end up with minus 3x to the 8th minus x to the 6th plus 2x to the 5th minus 21x cubed minus 7x plus 14. Okay, so this is just a nicer version of it because you can see I'm going to end up with 6 terms. So I have 2 times 7, that's plus 14. 2 times x to the 5th, that's 2x to the 5th. They're all there. It's just a nice order where I had the highest power of x out front and then in descending order. So does everyone agree everyone can see where that comes from? So I just expanded it and then I wrote it nicely. So now I want to find the derivative. What is the derivative of the first term?
Negative 24 x to the 7.
Good. What's the derivative of my next term?
6.
Minus 6x to the 5th, right? What's the derivative of my next term? Good. What's the derivative of minus 21x cubed? Good. What's the derivative of minus 7x? And what's the derivative of 14? 0, right? So this is my derivative. I should be able to verify using the product rule that this derivative is the same thing. So let's write out the product rule here. So go ahead and write it. F of x is 2 minus x minus 3x cubed times 7 plus x to the 5th. So what is going to be the derivative of the first function? What's the derivative of this function? Close.
Negative 1 minus 9x squared.
Very good. Minus 1 minus 9x squared. Right? So the derivative of 2 is 0. The derivative of minus x is minus 1. The derivative of minus 3x cubed is minus 9x squared. Is everyone okay with that? Okay. So derivative of the first function, hold the second one, so leave it alone. Plus the derivative of the second function. What's the derivative of the second function?
5x to the 4th.
Very good. And then leave the second function. So here you can see, okay, this is the derivative. It doesn't look exactly like this, but if I FOIL it out, it should. Turns out, if I do this, I get minus 7 minus x to the 5th minus 63x squared minus 9x to the 5th plus 10x to the 4th minus 5x to the 5th minus 15x to the 7th.
Shouldn't be minus 9x to the 7th. Yeah.
Right here?
Yeah.
Yes, it should be. Thank you. So now if I collect like terms, I have minus 24x to the 7th minus 6x to the 5th plus 10x to the 4th minus 63x squared minus 7. And we would agree that this is the same thing we got on the previous page. So this is the same answer. Question?
So on an exam, will you say that we have to use one or the other? Will you say use this rule?
No, I will say differentiate.
Okay.
And if you write your answer here, you're correct. If you write your answer here, you're correct. If I say differentiate and simplify, I want to see this. But a lot of times, if you look at final exams, there will be a whole page of derivatives. And it'll say, find the derivative and do not simplify. The reason why is we want to grade it as can you apply the product rule. And the product rule would be the derivative of the first one, holding the second one, plus the derivative of the second one, holding the first one. We want to see all that. We lose that when you simplify it. Although that, you know, right now the problems are pretty simple, right? Because it's only x to a power. We can simplify that pretty easy. Eventually we'll deal with sine of x, ln of x, e to the x. Simplification is going to be a lot harder to do. And so it will say find the derivative and do not simplify, because we want to be able to see, okay, what are you calling the first function and are you taking the derivative correctly? Eventually we'll have the product rule, the quotient rule, the chain rule, and combinations of all those in one problem. So you really have to be aware of how you're going about taking the derivative. Right now we only have polynomials, or we only have x to a power. So we can simplify that to x to a power, but eventually simplification is just not going to be possible. So a lot of times they'll say do not simplify. Does anyone have any questions on this? Let's look at one more.
So this is 2.4 54 and Wiley, is that what this is?
Number 8? No, this is just written number 8 from the book.
Okay.
Yeah. So number 8 from the book gives you this expression. It says, find the derivative. You can FOIL it. If you FOIL it, you will end up with 4 terms. Differentiating 4 terms. Not too difficult to do, right? You can do the product rule. Or you can do the product rule. Derivative of the first one, hold the second one, plus the derivative of the second one, hold the first one, and simplify. Both answers should get you the same. Both approaches should get you the same answer. But let's look at it doing the product rule. So what's the derivative of the first function?
Negative x. Negative
Yeah. Minus 2x minus 3, right? If you don't like looking at the problem like this, rewrite it. X to the minus 1 plus x to the minus 2. Now it's the derivative. A lot easier to see, right? It's minus x to the minus 2 minus 2x to the minus 3. Hold the second function plus the derivative of the second one. Hold the first one. That's the derivative. We can clean it up some. Doing some algebra, we get 6x plus 3 minus 27, x to the minus 2, minus 54, x to the minus 3. And you can verify that on your own. So you can go through the algebra, right? It's just algebra, simplifying. Does anyone have any questions? Yes?
So the 27 derivative is 1, so you just can get rid of it?
No, the derivative of 27 is 0 because it's a constant.
Okay.
So I could write
Plus
plus 0, but that would just be making my function look more complicated than it is. Question?
If we didn't simplify it on a test, will it be specified if we need this?
Yes, it will be specified if it will say find the derivative and simplify or just differentiate.
Oh, yeah.
So is the first part differentiating?
This first part, yeah, is derivative of the first one, hold the second one, plus the derivative of the second one, hold the first one. The next part is just expanding all that out and adding like terms. You see here, I end up with a minus 3x, and then I end up with minus 27 times 2, x to the minus 3. So I'm adding those like terms. That's all I'm doing there. Just not going through the algebra there. So the next thing we're going to talk about is the derivative of a quotient. So this is theorem 2.4.2, and it's called the quotient rule. So if I'm taking the derivative with respect to x of a function f of x over g of x, turns out it's going to be the derivative of the top function holding the bottom function. So I'm going to write this out, and then I'll use shorter notation. Take the derivative of the top function, hold the bottom, minus the derivative of the bottom function, hold the top, over the bottom squared. So another way to write that, if I have f over g, then the derivative is going to be f prime g minus g prime f over g squared. The negative is important. So order matters here. I have to take the derivative of the top first, hold the bottom, minus the derivative of the bottom, hold the top over the bottom squared. So let's look at an example that we know what the derivative is and relatively simple. So let's look at a function 1 over x. What is the derivative of 1 over x? I heard the correct answer. Let me write it like this. What's the derivative now? Right? So by using the quotient rule, I should find that derivative. So I have, so if I want to say f prime of x is going to be the derivative of the top. So I'm going to write this out, and then, so I'm taking the derivative with respect to x of 1 times x minus the derivative of x times 1 over x squared. So what's the derivative of 1? So I have 0 times x minus, what's the derivative of x? So I end up with minus 1 over x squared, which is exactly what we got here. So do you see how that works? Derivative of the top, hold the bottom, minus the derivative of the bottom, hold the top over the bottom squared.
Where'd you get the x squared?
This squared? Because the formula tells me to square the bottom. So let's look at an example. Let's look at number 12. So look at number 12. I'm going to go ahead and pull down the formula. So f of x equals x minus 2 over x to the fourth plus x plus 1. Find f prime of x. Derivative of the top. What's the derivative of the top? 1. See if I have room here. Hold the bottom, so it means x to the fourth plus x plus 1. Minus the derivative of the bottom. What's the derivative of the bottom?
4x cubed plus 1.
Yeah, 4x cubed plus 1. Hold the top over the bottom squared. So if it says simplify, you need to simplify it, which wouldn't be just more algebra. So on the top here, I have f prime of x equals, I have x to the fourth plus x plus 1. Be very careful with this negative, because it's being distributed through the whole multiplication of the two functions. So here, if I multiply 4x cubed by x, I end up with a minus 4x to the fourth. I would have a minus 8x cubed, so I have a plus 8x cubed. Here I have a plus x, so I have a minus x, and here I have a minus 2, so I have a plus 2. Does everyone see that? I kind of blended two steps together, but it should be... So adding like terms, my x's cancel. I have a x to the fourth minus 4x to the fourth, so I have a minus 3x to the fourth plus 8x cubed plus 2 over x to the fourth plus x plus 1 squared.
Just
Question?
so I understand that,
Mhm.
be real careful.
Mhm.
If you were to make that positive and carry that negative, so everything that 4x cubed plus 1 would be negative, but the x minus 2 would still remain the same.
You have to be careful because this whole expression is being subtracted here. So if I pull a negative in here, would that be the same?
Or do you have to make x
First-
negative x plus
First, multiply this term, you have 4 terms.
2 before you
And then distribute your negative to those 4 terms. So yeah, you have to be careful there. So here you can see I have a 4x to the fourth, a minus 8x cubed, a plus x, and a minus 2. But I have to change all the signs because that negative's out front. Question?
Do you simplify the denominator?
The denominator, the only way I could simplify the denominator if I had a common factor on top, I could factor it out and simplify it. But no, you can leave it like this. This is simplified. Factored is more simple than if I expand it out. Because if I expand it out, I'm going to end up with 9 potential terms, which is just going to make it more complicated. Because eventually, we're going to set this equal to something and solve for the value of x and make that true. So let's look. Does anyone have any questions on how to find the derivative?
me, just I have
Yeah.
a question. Why did you add 1 to 2?
I should have. Thank you. I didn't see that. Any other questions or concerns? Yeah, very good catch there. Sorry about that. Question.
So for the derivative, when you have the n and a constant in front of the x, you times that,
Yes.
but you always subtract n minus.
Yes. Yeah, so if I have a constant times x to the n, it's a constant times n, x to the n minus 1. Question.
Is it ever easier just to multiply it by the inverse and use the product rule?
Multiply it by the inverse and use the product rule. When we learn the chain rule, yes. Because you want to say something like x minus 2 times x to the 4th plus x plus 1 to the negative 1. Yeah, so we don't know how to do this yet. That's the chain rule. We'll learn that. Huh?
That would work though?
Yes. This is the same expression. So you could say derivative of the first one, hold the second one, put derivative of the second one, but I don't know how to differentiate this yet. We'll learn it though, and you can always use that technique. And we'll talk about that when we talk about the chain rule. Question?
Are you always just going to leave the bottom terms from?
There will be some cases where you will have the same factor in the numerator, and you can factor that out and simplify the denominator. But generally, yes, that this is squared. If I had an x to the 4th plus x plus 1 up here, I could cancel all that out, and my answer would be 1 over x to the 4th plus x plus 1 to the first power.
Okay.
Does that make sense?
Yeah.
There will be some cases where that comes up where you can simplify it. In this one, you just leave it alone, though. So the whole point in finding derivatives is so we can have this application of finding where our tangent line is 0 or where our tangent line is perpendicular or parallel to a given line. So let's look at some examples of going about that. So this is number 4. I think it's actually example number 4 in your text. So if you go to that, you're given a function f of x. X squared minus 1 over x to the 4th plus 1. So if I graph it, the function looks like this. And you're asked to find horizontal tangents. So they're asking you, what value of x do we have a horizontal tangent? We have a horizontal tangent when our first derivative is 0, right? So you're really asked to solve, when does the derivative of the function equal 0? Right? So we have to be able to differentiate it. Once we do that, we set it equal to 0, and that the rest is college algebra. The calculus is the derivative. It's almost the easy part. Then you set it equal to 0 and solve for the value of x that satisfy that. So looking at the derivative of this function, what's the derivative of the top? 2x. Hold the bottom. Minus the derivative of the bottom. Good. Hold the top over the bottom squared. First thing you should notice, the denominator never equals 0. Function's continuous everywhere. I never have a problem because x to the 4th plus 1 can never equal 0. And it's always positive, but that's not as important. So I want to set, when does this equal 0? The denominator can never equal 0, so the numerator has to equal 0. So we're looking for, when does, this would be 2x to the 5th plus 2x minus 4x to the 5th plus 4x cubed. When does that equal 0? Right? Does everyone follow algebraically? Negative, positive, positive,
So the
positive.
instructions for something like this, you said, would be find the horizontal tangents?
Find the values of x that give the function a horizontal tangent. Yeah, so you can see that there's a horizontal tangent here, there's a horizontal tangent here, and there's a horizontal tangent here. Right. And I want to find the values of x that when I plug it in, the slope is 0. this has applications into, physics. If I have a particle and I have the position of the particle, I might want to know where is the velocity 0. So I differentiate that, set it to equal to 0, and it will give me the x values of when it's 0. It's saying, oh, the particle stops when it's right here. If you think of throwing a ball up in the air, the position goes like this, right? And it turns out the velocity is positive or negative depending on your direction of down being positive or negative. The velocity is one way here. It stops at the point where it's the highest peak, and then it starts going again. So there's various different applications of derivatives. This is one of them. So I want to solve for when this equals 0. So if I add like terms, I have minus 2 x to the 5th plus 4x cubed plus 2x equals 0. What could I factor out to simplify my expression? A 2x? More so I could factor out a minus 2x because I don't like to deal with a negative coefficient on my highest power. I don't have to, though. Quadratic formula, eventually we're going to have to use, it accounts for any value of a. But I like my a to be 1, simplifies my life. Does anyone have a... So if I factor out a minus 2x, I'm left with an x to the 4th minus 2x squared minus 1. Right? And you guys know the 0 product rule. If a times b equals 0, then a equals 0 or b equals 0. So then this term equals 0 or this term equals 0. So when does 2 minus 2x equal 0? When x is 0, right? And then when does x to the 4th minus 2x squared minus 1 equal 0? What's this almost look like? It looks like almost a quadratic. This is actually a quadratic in the 2nd degree. Do you guys remember solving these in college algebra? My last class was like, nope, never did it. Never in your life did you solve a 2nd degree quadratic equation. You guys solve quadratic equations, right? Quadratic formula, plug and chug, right? Okay, so what we can do here, let u equal x squared. I can rewrite this as u squared minus 2u minus 1 equals 0. You guys would see that? Now you can solve this one, right? So I can say u equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Right? Yes. Okay, so simplifying this, I have I have square root of 8. Square root of 8 is 2 square root of 2. So I have 2 plus or minus 2 square root of 2 over 2. This simplifies to 1 plus or minus the square root of 2. This is what u equals. Right? So x squared equals u equals 1 plus or minus the square root of 2. So if I take the square root of both sides, I get x equals the square root of 1 plus or minus the square root of 2. Which is approximately 1.5 and minus 1.5. But this is, so x equals 0 and x equals the square root of 1 plus or minus the square root of 2. These are your answers to where the slope of the function equals 0. You guys are just maybe a little shaky on this part.
No, I'm actually really good at that.
All right.
How did you get the x equals 1 plus?
So I know u equals this. This is what u is. And u is x squared. So if I take the square root of both sides, I get x. So the square root would be the square root of 1 plus or minus the square root of 2.
Do me a favor, maybe right above the let u equals x squared, write the quadratic formation.
So the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a.
Thank you.
Right? And this solves any quadratic form a x squared plus bx plus c equals 0. And that will give you the solutions to the quadratic equation. So the trick here is to identify that this is quadratic in second degree, meaning I can make this u sub so I can solve for u, and then once I have u, just take the square root of that to find x. Yes?
Question. The second line from the bottom,
Mm-hmm.
you have u equals the square root of x squared, and then up there u equals x squared.
Here,
Yeah.
x squared equals u. I took the square root of both sides to get x. U equals x squared.
Right.
So then I can make this. So I'm saying x squared equals u, which equals this. And if I want to solve for x, I can square root both sides there.
It's like substituting in x squared for u.
Yeah.
Pretty much.
If I put the square root over u, would you be happy? Or if I say
Okay.
the square root of u would be x. Well, not really. I basically want to get rid of u. This equals x squared.
I think it's easier to say u equals 1 plus the square root of 2, and then under that say now. x
Yes.
squared equals-
So I kind of have that here, right? U equals this. So maybe I'll write it here. So u equals 1 plus or minus the square root of 2.
So therefore x squared equals.
So this is what x squared equals. Because u is x squared. So if I take the square root of both those, I get my answer. Okay, so I want to give a chance to... Wiley. Always walks me out. Okay. Most of the problems in this section are pretty straightforward. I want to go over... a few. So student view, you guys are section 2. So 2.4. Pretty straightforward. They're saying do the problem both ways and then write the derivative. It should accept both ways. So if you just do not simplify it, it should accept it. And if you simplify it, it should accept it. Same thing here. Quotient rule problem. This one has to do with, eventually we're going to learn the chain rule, but we don't know the chain rule yet. So this problem is going to take some time because there's a lot of algebra in it. Eventually the problem will take half a second because we'll learn the chain rule. So I purposely put this problem on here for the fact that you can appreciate the chain rule when we get to it. So we'll verify that the answer using the chain rule. This problem, let's see if I can go to full screen.
But
Number
you want us to
29.
do the problem without the chain.
Correct.
Would you just so you to take it? and then-
3 times. So you could FOIL it twice and then use the product rule, or you can FOIL it, you can multiply it out all 3 times and you have a long polynomial and differentiate that. But eventually you'll see why the chain rule is so beneficial. This example, I'm going to go over this example. Part A and Part B are pretty straightforward because it's just constant times the function, right? So the derivative is going to be constant times the derivative of the function at 3. So I think this will be. However, C and D, you have to be careful because you're going to have to, the derivative of this function is the derivative of f at 5 times the derivative of g at 5 plus the derivative at g of 5 times the derivative of f at 5. Do you guys see that? It's not just f prime at 5 times g prime at 5. You actually have to apply the quotient rule to this problem. The same, or sorry, the product rule. The same thing with the quotient rule. You guys see both those? Question.
Is it 3?
3, sorry, the previous, last class period I did one, it was at 5, but it's randomly generated, so yeah, at 3. And everything up here, all the information you need is given. But you need to make sure you're multiplying the right thing. F prime times G plus G prime times F. And then down here, the quotient rule. So there's more to it than just taking F prime times G prime. This example is going to be very similar to the example we did in class, but instead of setting the derivative equal to 0, I need to set the derivative equal to the slope of a line that's perpendicular to y equals x. So what's the slope of y equals x? 1. So what would be the slope of a line perpendicular to that? Negative 1, right? So I find the derivative, set that equal to minus 1, and solve for the value of x that makes that true. Turns out there's only 2 of them. If it says parallel, then you set it equal to the same slope. If it says perpendicular, you negate slopes, take the negative in the negation of the slope. And if it says where it's horizontal, you set it equal to 0. Those are pretty much the 3 things that will come up: a horizontal slope, a perpendicular slope, or a parallel slope. But the calculus is the easiest part almost, differentiating. Then setting it equal to minus 1, 0, or 1 is where you actually have to use your algebra skills. And you can probably expect it's going to be quadratic and solve for the quadratic, so get some more practice in quadratic formulas. Find the derivative using the product rule, find the derivative using the quotient rule, and then same thing again. So most of them are pretty straightforward. There's a couple applications that you need to know how to deal with.
That one, though, the denominator can't equal 0.
Yeah, the denominator can't equal 0, so what that means is the derivative doesn't exist at x equals minus 3. But you can still find the values in which the slope would be minus 1. But you wouldn't be able to plug in minus 3 here to talk about the slope. What's the slope at minus 3? It doesn't exist because the function doesn't even exist at minus 3. Does that make sense? But I could talk about what values of x gives me a slope of minus 1. So, oh, this x value, when I plug that into the function, when I plug it into the derivative, I get minus 1, meaning that the slope of the function at that point is minus 1. Does that make sense? Somewhat. The derivative represents the slope at any point. I want to find the point where my derivative has a value of minus 1. It means my slope of my function is negative 1 at that point.
You set it equal to negative 1.
You set the derivative equal to negative 1. You solve for the values of x that makes that true. In this case, you might set it equal to 0 if you want to find horizontal slope. They call a horizontal tangent line.
You do the quotient rule first,
Quotient rule first to find the derivative.
then set it to...
Set in this example, set equal to negative 1, because that's the slope here is 1. So the slope of a line perpendicular is going to be minus 1. All right, I will see you guys tomorrow. We will review for our first exam, which covers up to 2.1, and then exam on Thursday.